Hello everyone! In this video we're going to look at accuracy and precision when it comes to scientific data. Now let's imagine that we're doing an experiment where we're going to measure the density of a sample of ethanol. Now density, which you may or may not know, is mass divided by volume with the units grams per mil. It's the relationship between the two. So for our experiment, we're going to take a graduated cylinder and measure the volume of a certain amount of ethanol, and then measure the mass using a scale, then compare the two. The mass divided by the volume equals the density. So student A did 3 trials measuring the density of this sample. He took 3 different amounts of ethanol and measured the volume and the mass. His final values were 0.755 grams per mil, 0.756 grams per mil, and 0.756 grams per mil. These averaged out to 0.756 grams per mil. Now student B did 3 trials as well, and for her data got 0.764 grams per mil, 0.802 grams per mil, and for the third 0.796 grams per mil. The average of these gives a density of 0.787 grams per mil. What we want to decide now is, are these sets of data accurate, precise, or both? Let's start with accuracy. Now, when data is accurate, it is close to the known value. In this case, the density of ethanol is considered to be 0.789 grams per mil. Let's compare that to the averages that student A and B got. 0.756 isn't that close to the known value, but 0.787 is. It's only off by 0.002. So we would consider dataset B to be accurate. Now let's look at precision, which is the closeness of measurements to each other. Now there are formulas and calculations we can do to tell us exactly how far away our measurements are from each other, but for now we're just going to do a general approximation. Let's look at dataset A, where we have 0.755, 0.756, and 0.756. Now, the furthest distance between data points is only 0.001. So these data points are very close to each other, and we could classify this set as precise. Then let's take a look at dataset B, 0.764, 0.802, and 0.796. This data set is more spread out than the first one. The distance between the furthest points is 0.038. So we can say that this data set is more spread out and less precise than dataset A. So overall, we can state that sample A is more precise than sample B, and that sample B is more accurate than sample A. With sample A, we were getting consistent and repeatable results. With sample B, we were averaging out to the desired value, but because of its low precision, it has higher uncertainty. Thanks for watching, and feel free to check out some of my other videos.